So first we started with the local knowledge graph, just to reiterate, which is a local MCP server for you to have a graph database of your code. And how we did that is, to answer your question, we took code like this. So you have two code pieces, and we scan your entire workspace, identify the different repositories. And as this example here, we can see in this class, it's calling this my method and referring to this class bar, right? And what we created is essentially a call graph of your code. So when you load the knowledge graph locally on the server, it parses all your code, visits the AST through either tree sitter, or for Ruby, we use Ruby Prism, the actual Ruby parser that's newly integrated into Ruby, and a few other dependencies. And one thing that's going to be very key to note here is that we embedded this graph database technology called Kuzu into the binary itself. So when you install Knowledge Graph, you're actually installing the graph database as well. So the whole experience was that when you install this, you can just launch it on VS Code, and we can get a whole community around the knowledge graph. And this is specifically for not necessarily helping search, but helping the quality of your results. So I'm sure you guys probably saw the launch video. I don't know if you guys want to watch that all over again, but so that is the current state of the knowledge graph. And I also added that in the little current state section here of this design doc. Where is it? Current state should be in here. Current state. So basically, we have a local CLI that ships the graph database with it. And one thing to note that's important for the delivery people is that we built this binary. We build it for pretty much every single major OS out there. So we have Linux, Windows, Stan added Windows, binary signing. So that's the current state of the knowledge graph. And so the team was very focused on getting that released up until 18.4. And that is when the team started paying more attention to the server side. And Omar and Dimitri and Jan, who's no longer at the company, were focused on basically scaffolding what we need on the server side to be able to bring the code indexing to the server. So the knowledge graph as a service. Omar, do you want to kind of outline actually the current design?
Yeah, I mean, I already also started preparing something there in case there's some questions. So when we started to think about this problem about how we want to index the code on the server side, this is where I joined the team around May. So there was already some research done before about like benchmarking some different databases. So we approached this problem as we have the code in GitLab. We just want to have it in a different representation so that it can be queried for LLM and for AI in general. So what was discussed before I joined, but still like makes sense that based on the experience of from the search team that they already had like worked on the Zoc service for a long time, and this is pretty much the same problem. So we wanted to follow the same approach of like we want to make use of the Zoc indexer that we already have, but the problem is that we want to use the same library that was used by the Rust program for indexing the code. Does that make sense to do something similar in Go? That's why in the beginning that I hope I didn't jump ahead in the.
Yeah, we might just get like three levels there.
Yeah, so that's why in the beginning, around probably June or July, that we started to think about like, okay, using FFI because we want to bundle the Rust functionality into the Zoc indexer. So if you have seen some discussion before about FFI, that's why. That's the approach we took, and we started coding at that time around it. This is where we started to face some problems. So when we started to surface that, probably the conversation of FFI approached more people at the company.
Yes. Yeah.
I want like to follow up questions.
Yeah.
Because it seems like the Zook indexer is indexing differently than the knowledge graph. That like the Zook is using 3 grams and the knowledge graph indexer is using like the call.
Yes,
Yeah.
AST, yes.
Like the Zook is written in Golang, the knowledge graph is written in Rust.
Yes.
And then like is the reason why we are not using the Zook indexer only, like the Zook trigram based index can actually model the call sites as well, call graphs.
The Zook, so we took the approach of doing the static analysis approach. The primary reason that we went for doing the knowledge graph with Tree Sitter is so we could have full access to the AST. So we could do more advanced resolution like references and building a call graph.
Can it be done with Zook index?
From what we saw, it was the API wasn't as available. And we also wanted to build upon the work that we already were kind of POCing before, because I came in around March or something like that, and so we already had a POC, and that was in Python. And then there's a whole write-up on why we picked Rust as well, so we can go into that if you guys want. But yeah, just to reiterate what Omar said, what we originally had was the design. This essentially was, let's reuse the Zoic infrastructure that already exists. And so, is everybody familiar with? That's the main part. Is most people familiar with how Zoic works today? If not, then we should probably go over that.
I have no clue. But
Yeah.
also still, I'm still not clear on the problem. Like you have a knowledge graph in an MCP server, and that allows you to
basically do RAG against your code base at no matter the scale, the size of the code base. So essentially, think of it as
queries.
So yeah, so
overload the context window.
yes, exactly. So think of it as you launch. Imagine you have an LSP. If I'm sure everybody knows what LSP is. You can go to definition, you can go to references. We emulate that behavior right out of the box, essentially, for the agent to be able to do that. So the point is to be able to handle large scale code bases like the monolith and whatnot, to bring better context to agents. We started with code, but the goal is not just code. The goal is to unify it with GitLab.
So during code completion, the LLM could do things like, oh, can you give me the type definition when it's not kind of.
Yes, exactly. Or like, can you give me all the references to this code? Everything that calls this function, and it'll resolve it exactly, rather than trying to guess or do grep. And that's what we found in the evals as well. It was like a 7% increase on average on accuracy for the test.
So maybe the question to Dimitri is like, how does code search compare to this knowledge graph, like this graph approach? Is it?
I think it solves completely different problems.
Yes.
Zook, which powers exact code search, is more like searching your IDE. So exact substring matches, regular expressions. So no graph structures whatsoever. So we can't really use Zook library or to power the knowledge graph. But we wanted to reuse the infrastructure because Zook architecture itself contains self-registering nodes, so you can scale it really easy. You just change the number of replicas and you don't have to do anything else. And we want to ship it to Omni Plus as well, which is now no longer an option. That's why we kind of wanted to use FFI to bundle the knowledge graph into the Zook binary so that we can reuse all of the work we've already done.
Yes. So that he explained it perfectly. We were looking at the server-side knowledge graph. The original plan was, let's take the Rust binary that we have and put it inside of this Go binary, which is the Zoic service binary. And the Zoic service like imports Zoic itself, right? That Golang module, and does the task orchestration. So how Zoic works, I'll just pull it up on.
But my point is, I think you're indexing the code differently. You're saying, right?
Yes.
You're indexing it with trigrams, and then you're indexing it with the graph approach.
Yes.
And we're saying we need both approaches. That's the question I want to
They
raise.
solve
Like,
different problems.
They solve-
and the common part is probably GitLab in this case. So we need to talk to GitLab.
Sure.
Repository data, the diffs.
Yeah, but you're indexing code slightly differently. We're doing really two different databases.
It's a very different database, it's a
Yeah.
very different data store, right?
Yeah.
The one
Yes.
is like snippets of text and the other
Sure.
one's a tree.
Yes.
So I can see why they
But
are.
Yeah, but from a user perspective, what does it change, right? So what features one's delivered that the other one missed, and vice versa.
Yeah.
That's why we need both.
So
That's what that's a good
it-
question.
it's like using sed to do refactoring versus like refactoring in IntelliJ, right? The one understands your AST
That's the perfect way.
and the other one is just treating it as text.
But this doesn't solve the
Yeah.
question about why don't you use the smartest version for everything and not use the other version?
Because do you use ripgrep or something like that?
Yeah, I do.
Because sometimes that's the best, you don't use like sendgrep for everything and search everything as an AST. Like sometimes text search is incredible. I think I'm putting words in your mouth here. This is just my own.
If
Sort
grep
of-
comes with a lot of operational
Yeah,
complexity,
that's
Yeah,
exactly it.
is it really worth having it when you already have Visual Studio Code? I think that's kind of the question.
Right,
Yeah.
that's what I'm trying to, because it's, yeah.
Well, yeah, I'm not trying to raise that, but
Well, that's
So let's
the
get this-
problem. That's what,
Yeah.
the problem, right? Like, that's a,
Yeah.
From what you're describing, it sounds like if we had a graph-based indexing of the code base, we could, for example, render the code in the UI
Mhm.
and allow you to click on
I already-
function
yes.
calls and
I have that. I was gonna show you guys.
and
Yeah.
I guess the question that we should answer is, can we use the graph-based representation for full text search?
I know this. So this is gonna get into the database part. But I didn't want to jump ahead into there because there's
Just one last statistical related question. So in theory, can we build the graph index, the call index of calls on top of the Zook index? I mean, like use Zook to actually build the index of the calls.
I don't think so. I think Dimitri, you want to fill in there?
Probably not, because we just use trigrams to support these exact searches and regular expression searches. And it's just text.
It doesn't have the access to
So-
AST from what I
Okay,
saw.
so so
So
you're
like
are you using like the
The-
language AST
Yes.
parser for every language? we
Yes,
support?
exactly. Yes. And that is why we wanted to make the knowledge graph, the local version, the community edition, so that we can get the community involved, so that they can come in. Language experts like C, for instance, one of the customers wanted C implementation.
Are you using tree sitter?
And we're using, it depends on the language, but if we can access the actual language parser. So for Ruby, there's Prism, which is
okay.
the actual language parser. And because we're using something like Rust, we can statically
is it-
link it.
Is it better? Is it preferable to just using tree sitter as a standard face to all languages, or does that bring problems of its own?
It's yes and no. Like you can do things with tree sitter, but you get better access to the AST if you can use some native parsers. So for instance, if you use SWC for TypeScript, they have a module that you can resolve all of your node modules in. That's how they do the bundling, right? So you can access that functionality to build your better
Right.
graph search.
Okay.
Do we
But the default is tree sitter. So for Python, we use tree sitter.
Okay.
For other things, we use tree
Do we
sitter.
embed every language parser into that Rust binary? If we want to have like 20 languages, are we going to embed 20 language parsers into that?
That's the current approach. Yeah, we currently have 5, and the Rust binary I think is about 60 megabytes or so. So it's not too big. But yeah, that's the current thing, and we build it for every OS right now as well.
Does it mean that those language parsers have to build on top of like C, like
Tree sitter is a C library.
Yeah,
Tree sitter is the-
just
But
remind
they're
me.
migrating actually to Rust, their code base.
And does tree sitter? I've looked at tree sitter in the past, but does it use like a declarative syntax to define each language, or does it have a C level parser for each language?
It defines the syntax for each language.
in a
You
common
say, here's,
declarative format.
here's my language and
Yeah.
here's my
So,
struct.
so technically adding additional languages isn't like you bringing in a whole bunch
No,
of new
yeah,
libraries
yeah.
of code or
Yes, exactly.
CVEs.
We bring in new libraries where it
Yeah.
makes sense. So for Ruby, it made a lot of sense
Yeah.
because it's faster, but
Yeah.
they have access to every single Ruby.
It is worth pointing out though that that's quite a heavy, like, you know, just if you're bringing in Ruby and you bring
Yes.
like the number of CVEs and the kind of attack surface is obviously going to go up pretty quickly on that.
Yes, yeah.
So
And for some languages like C++, tree sitter is not enough. You can do a bit with tree sitter, but for static analysis, we're using the full claim compiler.
okay.
Yeah.
In a lot of languages, we would need that too. I mean, I'm just thinking like C#, requires that you have to make multiple passes to fully understand like the namespace
Okay.
structure.
What about
Yes.
if that was like run in its own process that was like run through an RPC or something like that, rather than
See,
bundling it all in?
I like that.
Because like the attack, like it just feels to me like the number of CVEs that you can bring into this binary is gonna really skyrocket. And also like the heavyweight.
Where you're saying
piece
like
of it.
it talks to the new language you
Yeah,
install.
so it sort of
separately.
shells out to
Yeah.
a parser
Yeah.
that's not linked
Can we write that
statically
down?
into the thing.
Yeah.
Because I mean there's the security side of it, but there's also the extensibility side of it.
Yeah.
No, that's a good point. We definitely
If you really want to protect this, you need to run like this in a micro VM or
Yeah.
like
Yeah.
in general, when you're running an MCP, it's running as the same user as
Yes.
the
Yeah.
person that's driving the IDE. So like if you
Yeah, on
Yeah,
the
so
client side.
yeah, on the client side, so
Yeah.
if you're just creating sub processes, it's not a security isolation.
Yeah.
You are talking
So-
even about on the local side.
On the local side.
Yes. This also applies to the server side to if we bring it to the server.
But on the server side, it's easier for us. Like on the server side,
Yeah.
we can say like we
Yeah.
run this in Firecracker and then
Yeah.
throw away the again.
And you just have a sort of some sort of RPC interface to do it between.
But you also have like a Chrome approach with the sandboxing sector
Yeah.
that should
Yeah.
work pretty well.
Yeah. You can start
And-
small.
and another approach, try to maybe compile that in a WASM and execute it.
It's also partly why we chose is to maybe be able to do WASM later on. But
Let me throw another question in. So for Circ, what can we do in Circ that we can't do in Elastic? Because in Elastic, we can also do like a trigram search.
So a while ago, we hit the limitations of Elasticsearch because it's mostly suited for human language, not for code.
Yeah.
We have a lot of issues, with our code search, false positives, all of that. And we had to switch to something different. After some evaluation, we found that Zoom fits our needs the best. We wouldn't discuss creating our own code search engine written in Rust. As an it will be much more involved. So we chose Zoom. And it has proven to be a really good choice. Right now we have over 48 terabytes of data in Zoom. So all paid customers of GitLab.com.
For cold search, Zoop is
Yeah.
also much cheaper to run. Like
Yeah.
the index size
Yeah.
is much smaller than in the case of Lab.
Also, yeah, Elasticsearch kind of you scale it by adding more nodes. It gets expensive as the data grows as well. I mean, also as a totally different data point, I know that GitHub invested a lot in Elasticsearch. Then now I'm going back to 2016, 2017, and eventually gave up on it because it was a terrible idea to use Elasticsearch for code search.
Yep.
Yeah.
But we're still using it for issues and
Yeah,
other
because
things.
that's natural language, right?
Yeah,
So
sure,
the
that's what I
stemming
would-
and all of that stuff.
Yeah,
Well,
the-
better.
The operational side of it.
Yeah.
Not, then you use the other one, choose both.
okay, we got a lot to get through. So let me get us to the architecture. So the way that Zoot works today at a high level, and so the original thought is to piggyback off of the Zoot architecture. We've had some we've done some research. Dimitri and I have been doing some research since then. But originally, so you can see if I zoom in here, we had like the Zoot Go indexer as like you can imagine these two were one binary. So we were originally going to put the Rust binary inside of Go in order to be able to, leverage all the orchestration that Zoic does. So the way that Zoic works is you have a task table, and I won't talk about the high availability part. We'll just keep it simple and talk about how does it get data out of Rails. And so we have a task table in Rails that every time you do a push to a branch, it runs it through the branch push service or whatever it's called. And it saves a task to the table, and queues the knowledge graph task in this case. And the service, which is like a cluster, essentially sends heartbeats to Rails, looking for those tasks every couple of seconds. And then once it gets a task, it marks that task as being processed and runs it through the actual indexing, which means it needs to talk to Gitly. That's what Zoic does. So it talks to Gitly, grabs whatever ref that it needs, does the parsing, sends it back to it saves the data to wherever data store it is. In this case, I think Zoic's also on disk, right?
Yeah, probably.
So it gets saved to a PVC, and in this case, we would also save it to a PVC because Kuzu is a disk-based database. We then once that's all complete, it sends a call back to Rails marking that task as complete. So that's how Zoic works today. Any questions?
Also keep in mind, just to add something, that there's quite some logic on the Rails side. I mean, Dimitri can also correct me if I'm wrong. That when the Zoc node pull the tasks, the tasks are already assigned for that node, because Rails picks if there's a new repo that has been, like, you push new code on new repo. Rails picks some node that was recently online. It has the most storage available. So there's some.
So it's a bit like Gitly in that respect, like, you know, how we assign a repo to
Yes.
Gitly. So we assign a repo
Right.
like a Zook node, and that's like dedicated.
Yes.
And so we,
yeah.
for the knowledge graph and stuff, that we kind of like made use of the same code base to do the same things.
Okay.
So this is using the PostgreSQL based queuing.
Yes. And so now this might not be the final architecture, so we'll get into that. But this is kind of the initial thought that we were going with, and it could be a good, like, we should think about sticking this is the thought with the team, thinking about sticking with this with the first approach. But I wanted to show you guys what I've been kind of tasked with from a business priority perspective, and show you essentially all the research that I've done in the past month. And something, I work a little bit differently. I don't necessarily like to just write about things. I like to code. So part of the ask from leadership, Bill and team, is can we get knowledge graph as a service, not just for code indexing, but I'm sure you guys are aware GraphRag is very popular. And I'm about to show you why it's so popular, but essentially, can we index other items than just code? So in this case, like plan items, CI/CD, vulnerabilities, those type of reports, can we translate those into a graph database? And so I wanted to show you guys something that I put together to kind of show you the value of both the code, what the code indexing will be as well. But I think when you look at actual GitLab data in graph format, it becomes a lot more compelling. So is everybody on the, does everybody have pulled up the knowledge graph notes here? If not, pull it up. And then everybody, you can go to, oh, I didn't even add it.
I don't have edit access on that document, by the way, Angela.
Oh, did I? Maybe edited?
Thanks.
Oh, why do you not have? That's funny.
I wouldn't trust me either.
Okay. All right, I totally forgot to add the actual link. So It's also in the agenda doc, but GitLab knowledge graph. Michelangelo. Oops. Okay, there you go. So if everybody can go here. So, and I know this meeting is also about how do we deliver things to people, right? Actually, sorry, GitLab org. If we can go to there. How do we make it easier to deliver these services to our customers? So what I did is I followed the delivery process. And so what you see here, what you're launching up here is a omnibus install with my custom code. I push it up to the regular build process, built it and with my custom modified code and deployed it to a Google Cloud VM. What's unique here is it's got the knowledge graph as a service running behind it. And what I mean by that, it's leveraging the data insights platform, ingesting the data and building the graph representation of this GitLab instance. And so what I did here, you guys can see like there's like a bunch of merge requests, issues, members added, etc. I gave 3 agents in like an isolated container curl access to this GitLab instance, and I had them generate fake data. So I had them basically say, hey, can you simulate a working environment? So what I want you guys to do is go through this and pick maybe a few merge requests or anything that you would find interesting. It's going to be really funny. So I created test users. One of them is Bill, one of them is Stan, one of them is Sabrina, and a few, and Dimitri and a few other people. And they're all like collaborating and building off of each other. So just while I'm talking, find like maybe a merge request that you find interesting and or an epic, something that would be like deeply nested. I also got runners set up with this, so you guys can see there the pipeline data was generated, and also some vulnerabilities were generated as well. I think it should be all available to see. Maybe not the stuff that you need access, like secure, but you should be able to see the issues. It should be all public. Let me know if it's not. Okay, so we can say something? Okay. So now you guys can see there's a little button on the top right here. So I put together, so there's the existing knowledge graph UI. If you guys haven't seen it, well, you're going to see it now. So there is an existing knowledge graph UI, and I modified it and deployed it to the knowledge graph web service. And this is just like a gimmicky way to show you what's happening behind the scenes. But essentially what we have here is a graph representation of GitLab, and this is leveraging the data insights platform as a backend. And so we've got the VM that we've got deployed, we've got my cluster, and that cluster is talking to the VM and reading that data in real time and loading the graph every 5 minutes, essentially. And so if I go in here, I can click in and I can click into this group, which is one of the groups that I made. So the top level group is GitLab org. The group below that I created is, here's a mobile section for all the mobile apps. This is the Android devs. We're gonna say something.
Oh, you want to share your screen so like.
Oh yeah, so Adam can see. Sorry, Adam.
It's also recorded, so people can see this cool.
Yeah, I should have shared for a while. Okay. All right, so we've got, you can go in here and then you can click in. So I think this is a project. So if I click this project, here are all the actions associated with this native Android application. And I can go in, I can see all the users that belong to the project. These are their membership accesses. And then I can click on this user and see that user's interactions. So I can see what type of interactions that user took. And so we also do this with code indexing, and the goal is to marry the code indexing with the SDLC data here. But what you're seeing is what the LLM will see, and why this is so powerful is because unlike traditional SQL, as you guys can imagine, to do neighbors like that, neighbor searches, and to do these type of graph queries, you have to do recursive. Hey, Shkar. You have to do recursive SQL queries, and it's a little bit harder to get neighbors data. And what you're seeing here is what we're actually going to emulate with the agent. But if you can go in here, you can, and you guys can play with it yourself and click around. It's all being served from that namespace graph database. In this case, we got some issue notes, and it's capturing all the comments. We've got this merge request here. I can click on any of the merge requests. And yeah, so this is just like a little graph representation of this GitLab instance. I can even look up Stan, for instance, as the node, this user node.
I don't think you could
Did I
make
click
memory
it?
for that.
It might be a little bit buggy. I haven't gotten all the bugs. This is like something I put together in a week, so it might not clear it. Can refresh.
There it is.
We did Stan. Maybe it'll do it this time. Oh, here you are.
There. No neighbors. Oh, there it is.
It's a little bit buggy.
All right, so let's
It should be more like an explosion, but I think it's buggy.
Yeah, it's just jumping back and forth.
Yeah, it's not loading everything.
Mhm.
But either way, so you can see essentially what's going on here. Now this is cool. But now to show you some more stuff. So what you can do with a graph database, I'm trying to explain here that it's both a sort of like an analytics product, but also a RAG product. So the graph database can be used in multiple ways. This is something that I discussed with Nitin about. And you can use graph databases to get insights into things that you wouldn't normally be able to easily put together. And you definitely do not want to run these type of queries on a production Postgres database, right? And some things that are necessarily not available with ClickHouse. So in this case, I'm getting aggregates, an aggregate MR count by user, and the job counts by user, and how many pipelines they triggered, all in like a single table here, just with one graph query. And then you can also get their success rate. So this is just like the little agents that I had together that were collaborating. Here's another one. This is kind of a play on the GitLab Wrapped, but this is showing all of the people who have reviewed each other and the top reviewers of each other, right? So Stan has reviewed Dimitri's work the most, right? Sabrina has done Michael's the most. These are just agents, and when I had the agents go and create things, I had them focus on specific projects. And so we'll see, I'll show you exactly why this can be useful. But these are just some of the reporting. So here's an issue resolution flow. This is another graph query. And so you can actually get a table of all the issues on whether they've been closed or open, and the actual closing MR, and the closing MR's author, and you could even add more connected data if you want.
So on that, Angelo, like
Yeah.
I don't want to drag us down into this
Yeah.
too much, but we can talk about it, maybe table it. But like, I do think we want to think very hard about whether we want to end up with two analytic solutions, right? Because we're going all in on ClickHouse now.
Yeah.
Looking at these, like these are things that ClickHouse could kind of eat for breakfast, I think. As far, I mean, I don't know, maybe not, but I think we should. I think there's a lot of great useful things in the knowledge graph. But my personal kind of gut feel, without more information, is I think we should stay away from the analytics side, because we've kind of gone in on ClickHouse there, and I think we shouldn't muddy the.
That's what I talked about with Nitin, and he thinks they're complementary solutions versus
Those queries there in particular. I mean, I think
It was
we could run
the
those.
same thing.
We could run those in ClickHouse. You know.
Yeah.
For one question, because if I remember correctly, the graph analytics stuff is using Kuzu under the hood,
Yes.
and I see on the previous slide that it runs in
Yeah, we'll get there. We'll get there.
no clustering technology, right?
And it's archived too, but
It's
it's a different.
archived.
Yeah, we'll get there.
It's no longer maintained.
Okay.
Yeah.
Okay, so that's actually quite.
Yeah, we'll get there. We'll get there.
I just saw that in memory on this local.
Yeah.
Oh yes, it's in. This is being served from the web server from disk. Yes.
That's kind of a cool.
A point to
That was the point. Co-locating it. So
point to Andrew's this thing. So in ClickHouse, I mean, you can do like relational queries, obviously, right? But you know, when the moment you get like 2-3 levels deeper, it becomes a lot more complicated and like a lot more difficult to have optimal query plans for those kind of things. So like one level, like this is a pretty simple scenario you're showing your reviewers,
Yeah.
right? But the moment you go like, you know, or 2 projects beyond or something like that, then it becomes much
Yes.
more
Yeah.
non-performant, right?
I
Like as an example here, you can for this epic delivery, you can traverse all child issues and even pipelines if you want, and look at their completion rate. So in this case, is like epic delivery health. I think we do something similar planned today, but through a bunch of recursive queries.
maybe like if we can show an example of where something doesn't work in ClickHouse, but I mean ClickHouse.
Yeah.
I will also say that my only graph database experience in production is Neo4j, with a very large set of data.
Yeah.
And the same problems that blow up in SQL do, you know.
Yes, they do. Yes.
Like graph databases aren't like magic.
They're not.
right?
Yeah.
They still have,
They have
and
operational
we had endless problems with Neo4j.
Yeah.
But because of the graph size that we were dealing with.
Now I just wanted to show you guys the cool part. So this is just all visual representation of what's happening, right, with the service. And the main thing that we want to do is have an agent talk to this service, right? And be able to traverse the graph database itself. So I'm going to pull this up. I intentionally have an open source agent just to show you that it's only the API. There's no magic under the hood, and it's only MCP. I'm even going to show you the config so you guys can see. So I've got it loaded up to KG API dash the URL and dash MCP. So this is my MCP server. And so the UI that was being served is now also being served on that dash MCP URL. And so you can ask it, you can pretty much ask it anything that you want about this GitLab instance. It's very, I didn't think it would work as well as it does, but it does. So here's a really funny one.
We know who this is gonna be.
So
it's gonna be someone else.
so this one's gonna be funny, but using knowledge graph, can you identify who's the single point of failure in the company? OpenCode doesn't always work the first time. It doesn't always connect. I don't know why. So let's see if it actually connects the first time.
Since it doesn't have access.
Yeah. Well, let me retry it. I don't know why OpenCode refuses to connect sometimes. Let's try again. Okay. All right. All right. So it generated the plan here. It's going to first go ahead and get the schema. And I'll explain the technology here in a little bit, but it's able to traverse. What I gave it is a subset of tools. So actually 6 tools only. And so right now we have a problem in our current AI gateway and our current AI stack where we're writing tools for, and not all these queries are perfect, but we're writing 70+ tools to retrieve and fetch information through all of our GitLab components. So one of the main things that we can solve with the graph database is when you give it the ability to traverse the graph database, it can actually, you compress the amount of tools that you need to fetch that information by, like in this case, from 70 to just 6 tools, and you just give it the tools it needs to be able to explore. So kind of similar to GraphQL, but you can't do this in GraphQL because our GraphQL schema is way too big, and B, it doesn't have the neighbors approach and or the aggregate abilities and some of the other query ability that it has here. So it can also find shortest paths between nodes. it can do more graphs things. But yeah, we can see that Stan
Sabrina.
is pretty high risk in
So,
the company here.
Which are projects were indexed in this case?
So this is all the projects in my this fake GitLab the VM
all-
instance that I deployed.
It's all fake data.
It's all fake data. So
Yeah.
but if you guys want to find like a merge request on the
React.
on the thing, you can. I also created two bot users that have like a contract. They're like I made them contractors. I can be like, what about the contractor? Any risks there?
You should be fine.
Yeah, this is probably not
Oh, that's like Bill once.
probably not the best example.
Available last week.
And so this case, it's gonna identify the users that have contracts, and it's gonna explore their related nodes, what nodes they touched on, and specifically give me the projects. In this case, he's one of these contractors, Dimitri. Is the sole architect of the Android app here. He's an AI systems expert. He maintains that. And this is cool. But now I can be like, which what's an example? Which contractors have, let's do triggered the longest pipelines. It might not work. I've tried similar things, but you can ask questions like these that you wouldn't be able to ask with Duo today. And of course, you can ask about specific items that you want. So like I have a merge request. I have 7 downstream merge requests that block this merge request. Tell me about all of them, and it'll do it in like a few queries. But here we got some of the longest pipeline offenders. So it gives you the exact merge requests associated with those pipelines. Total pipelines Dimitri triggered, which is with the average duration, 33 minutes. It's pretty cool. You can ask things that you wouldn't be able to.
Just to play devil's advocate to Andrew's point, if you had MC server connected to ClickHouse,
That was my question.
I mean, would you effectively be able to do something similar, right?
I'm not sure.
I have one other. So that was my first question. I mean, we should definitely try that as well. Like, I love this demo, by the way. This is super cool, and I think it's really exciting. But like, it'll be interesting to try the ClickHouse one. The second thing I had was like, is there any sort of like security or authorization or filtering, or like how are we going to do that?
Yeah, so that's all in the design. I didn't have time to put all that together. It was a lot of work.
Of course, yeah.
But I'll pull up the doc so you guys can see it's all written out. So if you guys go to the design doc link, and there's a security section, dedicated security section here. And here it is. Yes. Okay. So there would be, in this scenario, if we made a graph database of GitLab, the idea is, this is what Dimitri and I have been doing research on. Essentially, you would have 3 layers. So the first layer would be very similar to cells. You would segment by top level namespace, namespace. What's in whatever database we pick, it has to support multi-tenancy. Otherwise, it would just be a non-starter. Kuzu supports that because it's literally a file, right? So you can have namespace GitLab org as a file, and the only way someone can access that file is if there's a bug in your application.
I mean, I don't think, like, obviously there's a lot of security that is much more fine-grained than names.
Yeah, that's the first layer.
You're adding more.
Yeah, this is the first layer.
Okay,
so
so I thought it was.
yeah, we did research.
Okay, yeah.
So the first layer would be separating the data. So this would prevent hopefully S1s. In that case, the second layer would essentially be every node. So as you index this graph database, every node will be attached with a traversal ID. And so what you guys saw there when it was doing its own exploration, it wasn't actually running its own Cypher queries under the hood. It was generating JSON, and that JSON we can actually construct our own query and add traversal ID filtering for every single query that you want to have. So this cuts down the amount of data. This doesn't handle every permission issue because this only goes to the project level, right? But the last part we would do, and this is why we would want to use something like the Data Insights platform and ClickHouse, because they already build these traversal IDs for the own data modeling. I think Adam can correct me if I'm wrong, but the last thing that we would have is a redaction layer. So essentially because we can control what Cypher query is run against the database, we would be able to validate every single node that comes back in the response, and we would query Rails with just the node ID and the node type to filter out any of the nodes that the user does not have access to. So those would be those are our initial thoughts on the security. If you guys have holes you can poke into it, let me know. But yeah.
So you'll have to have a fixed set of tools, right? You'll have to have a fixed set of tools which tell it exactly, because you can't ask the LLM to generate raw cipher.
Yes,
right?
that's what I have. There's 6 tools for different traversal types.
Yeah, and you need to then inject the traversal IDs into
Yes,
those.
exactly. Yes.
So you parse the cipher that it generates,
Is that-
and then basically add additional filters in.
No.
No, it's JSON.
Right.
Cipher
Okay.
fixed.
Right. Okay. Right. Okay.
The LLM can't generate arbitrary.
Right. Okay. But it understands how does it?
That's why it was mind blown, because it understands how I basically created some tools like aggregate nodes and traverse. And so it can specify the nodes that it wants to traverse in the graph and the direction, and it knows it very well, as you guys can see, with some hiccups, of course. But that was the part that was really mind blowing to me, that it was able to pick up on. But it's good for us for a security perspective, because we can add in all of the filtering at query time. So.
Is there something for free we get with the new ODZ architecture that helps us do the traversals better?
We talked about that with Dimitri, and I think the new authorization stack can help with that. The SpiceDB we plan to use is actually building the graph of resources.
Yes.
Which we can then query to give you the authorization decision. That's right. The details.
I worked with Mo actually on this to see if we could come up with proof of concept. He gave me, I'll show a video later. He got AuthZ and Envoy working essentially, where you can talk to the knowledge graph directly. But having an auth service will really help this, as you can imagine. So you can just quickly look up nodes, and you don't need to call back to Rails for that or anything. So, but yeah, that's a TLDR on security. But yeah, so that's kind of the demo that I wanted to show of why this is valuable, right? You can ask things you cannot ask today at all. It's pretty much a whole product in itself. And so now you can imagine, I didn't get to set up the code indexing MCP, but you can imagine now you're talking to your GitLab instance, you can traverse all of this data in your GitLab instance, which in case it has pipelines, vulnerabilities, I can even pull up a vulnerability example. We can even build off of this. Did any of these pipelines trigger vulnerabilities? And because we capture that in the namespace indexer, it can go and traverse those things. It might not work. I haven't tested all of this. This is like me testing in real time. So we'll see if it actually works. But yeah, so that's hopefully kind of explains the type of questions you can answer here.
What was your concern? Maybe to get back about this point, because I'm still curious. What was your concern about clustering in Kuzo?
Yeah, so I'm seeing that, for example, we are using the where something in. So on large data sets, those queries are going to be super long and super expensive.
Yeah.
Then on GitLab.com scale, we can't just run a single instance of a knowledge on the graph database. Like it has to be partitioned.
Yes.
Yeah, it has to be sharded.
So that's part of the design. We would be sharding by top level namespace until we have cells. Then each organization would have its own shard. And in the design also, what was the first point you said?
I mean, like the queries.
The queries, yes.
Data sets might be enormous, right? On
Ye-
GitLab.com, if someone wants to run a query on the like the GitLab.com realm, then suddenly if we have like all of the projects in the list of IDs, like this query is going to be like 1
Yes.
megabyte large.
Yes, so and we'll have to have, part of what that's going to be some of the art in validating the Cypher queries. Michael is really good at that stuff on the knowledge graph team.
But would that even work on like GitLab org?
So I'm about
sites, we have
I'm about to show you.
100,000 issues. Like
This is 200 million nodes. This is with Kuzu. This is why I'm a little bit sad Kuzu got archived. This is 200 million nodes and 70 million edges. Or sorry, 200 million edges, 70 million nodes. 10 of them are issues and 70 or 60 of them are merge requests. And what I did here is I used a Faker Rust package. So it generates like text blobs for like realistic looking titles, realistic looking descriptions, paragraphs. And 5% of those descriptions have descriptions that are a megabyte in length. And so in this test, so this is it running like basically some of the more advanced queries, but this is basically some of the response times here. I don't know why the video's taking forever to load. Let me go back.
The video can't handle the nodes.
So yeah, so this is me clicking around in that size of the database. The database uncompressed is 95 gigabytes, and Kuzu compresses it to about 25 gigabytes. And when I talked to Adam on the stats, our GitLab org namespace, I think, falls under this. I think in Elasticsearch it's 15 gigabytes or something, right, Dimitri, or something? For GitLab org.
is Kuzu like reading this data from disk, right?
Yeah, this is on my Mac on disk. It's very impressive, this database. And there's very similar databases. I actually found a database yesterday that's just as popular as Kuzu. I think it's a new thing because everybody knows that graph databases are the mechanism for RAG and AI agents these days. So yeah, that's a little bit of the homework that we did on performance side. And the other thing to note here is the iteration plan would be we would have the SDLC data as its own graph database, and then each project would have its own graph database, and we wouldn't try to marry them into a single database because that would be a large data problem for sure.
When you say each project, you mean code. So the code for project is in its own database,
Yes.
and everything else, the SDLC data is at, say, top level.
Exactly, yes. And hopefully with the tools that the agents have, so I'll pull this back up here, the thing, hopefully with the tools that the agents have. So this is the namespace graph, like you were saying. And then underneath here, these are the different code graphs for each project. And I'm hoping that, like, I haven't tested it, that the agents can traverse these graphs well. I don't know why these don't have, maybe they didn't parse. But yeah, hopefully they can traverse the graphs well. And know when to be able to traverse. John had some ideas on how to connect the project code graphs to SDLC graph, but yeah, just wanted to show that demo. There's definitely a lot in how I got the whole thing spun up because again, this is a cluster that's running basically data insights platform, the knowledge graph service plus Kuzu, knowledge graph web server and the indexer. It's listening from Postgres directly. So we are not putting any operational burden on Postgres. I made very little Rails changes. I opened a few endpoints. So on the Rails side, we need to open a few endpoints to make this happen. But it's following data engineering, hopefully data engineering best practices. So it's reading from the database in a non operationally load heavy way and indexing it and
To be
leveraging.
clear, that's the logical replication, right?
Yes, that's the logical.
You've enabled logical replication in Postgres to basically, you know, if you're not familiar with logical replication, you basically can say, I want to be notified about these changes on these tables, as opposed to getting the full data stream, right?
Yep.
But that's a key point, because I don't think we enable that on GitLab.com right now. We have streaming replication on GitLab.com right now, saying we want to add a client that does logical replication. I think we're trying to do that for cells, right, Camille?
Correct.
We're potentially using logical replication for cells for.
We're gonna be
something?
using logical replication for sure.
Yeah, but
Like today we were kind of trying that through Siphon,
Mhm.
but like that's the idea. Like because
So-
like we need this is the whole reason why we are adding sharding keys.
right.
First is like to do isolation of the data, but second is really like to attribute exactly which parts of the data we can just move in full before the relations defined by the in a database.
Right.
Is it organization mover?
Yeah, or Hoover.
Yes,
Yeah.
yes, but it's gonna be using underneath the Siphon.
So you're already gonna be using something like Siphon for
Yeah.
that part. So
Yeah,
that's a pattern, right? That's
Yeah,
basically-
exactly. So logical replication into Siphon into some destination, right? Or something.
Yes.
Are we doing that for like ClickHouse stuff too?
Yeah.
Yeah.
We are
So that's
yes.
actually three.
Yeah.
we are using Siphon for the ClickHouse, but like the transfer layer is built on top of NATS, basically.
Okay.
Yes.
Yeah.
This is also built on NATS as well.
So good. We already have 3 cases where we need to do this, right?
Yeah.
Sorry, how's this built on that? Because I saw it was polling the Rails to find out about things that need to be
Siphon sends it
updated.
to NATS.
No, so the original architecture that I was showing you is completely different what I'm showing you.
Yeah.
Okay.
And that's part of the research.
Yeah.
And to add, Dimitri and I were talking to Adam, and apparently they wanted to do this. Dimitri, you want to explain for Elasticsearch? Have you guys met with Siphon?
Yeah, so this is our third time when we discuss Siphon for different features. So the first one was advanced search, because we want to subscribe to certain tables and get notified from data changes. The next time we met with Adam to talk about advanced vulnerability management, because it also uses advanced search. And this time it's it's for advanced search, it's for remote traffic.
Yes. So, yeah, I basically, rather than, trying to write about it a bunch, I try to actually build it. And so I got the cluster up here if you guys want to see the cluster.
I don't think we can get away from Siphon and NATS.
No,
we
I mean,
have
that's
these-
good. I mean,
yeah,
it's a good
exactly.
sign that
Yeah.
everyone's using the same pattern. I just think it sounds like we need to be able to support that broadly.
Yeah, exactly.
Right?
So this is the cluster I have up here that's talking to my GitLab VM. So we got the indexer, web server. I've got Siphon main and Siphon CI because CI is a different database.
There is also sec right now.
Huh?
Sec.
Security,
Security
yeah,
database.
security, you're gonna need
Yeah.
security.
There's no, yeah, it'll come.
And then
Yeah.
another one.
Once.
Well, I
once
did
you start-
vulnerabilities. Vulnerabilities was in the main
Oh.
I mean, they
tables.
did a huge decomposition, right? So that is now.
Oh, okay, okay. I didn't know that.
So this is,
And I found some things in Siphon as well. So I'll probably tag Adam. Adam, I'll probably tag you in a review soon. But is while setting this up. Oh, can you hear us? Yes. Hey, how's it going? Okay. So yeah, so that's what I've got set up here. I got the
so
GitLab
what's
running.
running on Omnibus then? I know Postgres is, right?
Yeah.
What else is running? I mean,
The
this is-
Rails.
What's that Postgres there?
This is a different work.
Study.
This is the research agent. Sorry.
That's a different thing. Okay.
This is the GitLab research agent that I built. This is the original knowledge graph, actually. So non-GitLab research agent stuff is the stuff you should be paying attention to. I don't know how to filter.
You can go to the cluster,
you can go to
drop
the
down,
label.
and then
Where?
At the top, there's a
go
pull down.
Yeah.
The-
Go to the
the-
red cluster.
Up.
Okay. GKG cluster. That helps.
Okay, so basically you have GitLab running as an omnibus, and then you've hooked into it with your this Kubernetes deployment, right? Is that
Yes.
what I understand?
Yes.
So this is kind of,
I configured the CIDR addresses. I can show you the
Yeah.
config if you guys want to see later.
yeah, so you've enabled logical replication on this omnibus thing and you've put it, you're basically funneling into this cluster.
And the data is live. So I mean, you can go in here, you can see the logs and
Cool.
see it actually pulling Postgres as well. It's just, I'm not gonna lie, it was a pain to set up all of this. Like it was a week and a half of just nonstop.
So we need to add it to get and all those
We've
places.
got a whole session on this.
Yeah.
But yeah, that's knowledge graph. Hopefully you guys can see like some of the value in it. I know there's questions on like whether we should use ClickHouse and whatnot, but I still think like either way, all this stuff is super.
Even if we don't put them head to head, like maybe the same technique would be useful for ClickHouse. Like
Yeah, we can
you
try
know,
it for sure.
because there's going to be super useful information and I don't think like there will be some information which probably makes more sense to be in ClickHouse and
Some yeah, that's exactly what Nitin was telling me though. Is like
Yeah.
at Twitter they used he said that he came in, they used Neo4j and they ingested all the data sets. They had 1 million data sets at Twitter apparently, and they found all the loosely connected data sets and deprecated them and saved $300 million for an annual cost. So I think there's definitely use cases that graphs can do that, analytical
I mean
databases.
without doubt.
So yeah.
But if you were to iterate and prioritize, right? Like it sounds like you'd want to have that ClickHouse stood up first and try to get that ironed out, all the issues ironed out before adding another data. Because especially the graph database world is high flux right now, right?
Yeah.
We're seeing it's not quite production ready yet, right? We're not confident that even though Kuz is highly scalable, like putting that in production and then suddenly you find a bug in it. Who's maintaining that, right?
Exactly. Well, no one right now.
No one is now, right? Like you would have to do that. You would have to delve into C++ code, right?
Yeah.
I think that the pattern for doing authorization it would probably make sense to replicate that between what you do in ClickHouse.
Right.
So that's
And what
exactly
you
why I
do.
think using ClickHouse as a data lake would probably be the move because they're already building that data.
Yeah.
And that's what I had to do manually. So in this case, there's no ClickHouse. I'm consuming from. I wanted to learn myself anyways.
Yeah.
I'm consuming from Nats and Siphon directly,
Yeah.
and I'm modeling the data. I'm saving it to an S3 type of bucket essentially, and that's using Delta Lake, which is like the same thing as Apache Iceberg, basically. And so yeah, but either way, we need a data store to query from. Like Knowledge Graph cannot receive it.
But there's also because you've got an agent that's kind of got open-ended access to like all the data for all the people, you need to have a really good solid way of basically stopping it from getting stuff that it accidentally
1000%.
shouldn't get access to.
Yes, 1000%.
For our authorization, we do plan to use the SpiceDB, but the SpiceDB is using PostgreSQL under the hood. It reads data from the PostgreSQL to build the graph of resources.
Yeah.
But it is not clear yet whether this is going to scale on GitLab.com size data set, and maybe for SpiceDB we also need a proper graph database. It's hard to tell yet. That's in problem.
SpiceDB, we have two scaling options. So one of them is we could be using Spanner, but like last I think 2 or 3 weeks, like PlanetScale has actually like opened their commercial product. They have essentially Vitesse for Postgres, like a native, not the old Vitesse MySQL code base, but they have built, it's called Neko or something, like a native Vitesse for Postgres. And so for .com, we could probably be using Postgres powered by PlanetScale with SpiceDB.
There's also Sugu's
Sugu's thing,
and he's doing his own one as well. So there's multiple Vitesse for Postgres coming.
Yeah, so Sugu founded Vitesse, right?
Yeah. But
And he left.
Yeah.
He announced that they were going to work on Vitesse for Postgres, and then PlanetScale announced their own thing. And he had no idea what they were talking about. So I don't know how real this thing is.
But it's a production chief, and we can test. Like ideas don't run. Like, we need to have a production system.
Has anyone checked in with him recently? The last time
I know they raised a lot of money, hired a lot of
good people.
So I actually put more money on that then, but who knows?
Yeah.
It's still early though, right?
Does it make sense for like for knowledge graph or any other service in the future that when we build such feature, we try to make the tools lead from ClickHouse and Postgres as just way of iteration and boring solution. And then when we see that, okay, customers are using it because we see that these tools being called and they are slow, that we start preparing knowledge graph and we see, and then we see the number and probably like we switch like in gradually and we see, okay, now knowledge graph, we can see here that it's actually faster for us, pretty much like Elasticsearch and Zopt. Like it's like the same feature on the top, but behind this different technology. Does it make sense to follow that approach? Or we know in advance, no, like we need the graph database because it's useful. We know that. So how the answer to answer the question is like new service. Which approach do we take? Okay, that's
Look, if the data's in ClickHouse, right? Right now, and customers are running ClickHouse and they've got this data there, like it seems to me like it would make more sense to say, okay, let's try this out and connect it to ClickHouse. And then the customer's like, wow, this is incredible. But it's like whatever, something wrong with it.
I think
for largely nested data sets, like how many ClickHouse queries would we have to run?
That's the only problem that I haven't really tested with ClickHouse. That's why
Hundreds or thousands of queries.
the graph database needs to be able to not load everything in memory. So what I built is all streaming. So it runs data fusion queries, but it processes row by row to build all the relationships and then saves it in a temporary data store to be loaded into Kuzu. So it's like another ETL process on top of it. But I don't know if we would be able to run those type of queries on ClickHouse.
I think the bigger risk with ClickHouse is actually that you've got 20 teams and those teams are just sticking tables like willy-nilly into ClickHouse that are not particularly well, they're not following the Snowflake. I forgot what the proper model for building things. And we have this mess of schemas in there. And that's kind of difficult for this AI to kind of interpret because it's just looking. There's a table there.
You're saying it's
Sort of underscore final last table.
Yeah, so that's why graph is so popular now. Is because everybody's realizing agents can traverse graphs.
Yeah.
Just like a human.
But I think that if we took a bit of care in the way that we structure stuff in the ClickHouse database, or at least kind of gave it like some of the schema, we might be able to get a bit of like might be able to help it along there. Maybe not as well as graph, but like if we wanted to run queries where we could say, who's I don't know which team is, or like of the jobs that have failed over the last month, which of them are using the most CI minutes, like kind of weird queries like that. Like that, I can imagine, ClickHouse is just going to be good. That's like a good analytical database, but we have to have a way that the agent can kind of understand a well-structured schema so that it can emit that query and not just say, hey, here's 50 tables, go figure it out, because that would be
and also to that point, and your point as well around, is there an iterative solution around, using what we have today, building essentially, hey, here's our interface for our service, and then we could swap out underlying, implementation later. Because I know that the tools that you have are a representation of your implementation to some degree. You're almost saying, hey, here's the way this thing is structured. Is there a way that those tools could just not expose the underlying architecture?
If you're saying transfers the tools that we build SQL instead of Cypher,
I guess,
I don't know if that's
what I'm saying is to some degree keeping your interface not you're not exposing the underlying, hey, here's how this, because right now our interface that we're handing to the agent
it's a JSON schema, yes.
Well, it represents the everything that's the implementation details.
I definitely feel like when we're discussing this we're building out this multi-service architecture. And when we're discussing when to create a service, I think we should talk about the stateful layers and what is each stateful layer good for. Like we need a few stateful layers for certain. So we need to define, this is analytics but not graph. Like, it has to be clear what the stateful layers are because the customers can't operate tons of stateful layers, right? And so
there's another dimension, 100% agree, but there's another dimension which I've spoken more about before and I haven't put it, which is derivative versus primary data
Yeah,
source, right?
exactly.
Because you know, some data source, if we lose them, you can rebuild them. Others
need
you
some
can never
lineage
lose
so
them.
that you can restore. Yeah.
Yeah.
The problem with like regenerating derived data is like, if we're first using an event approach to build the derived data, like we then need to find a way to trigger these events again.
Siphon has got something along those lines built in.
So I had to build I have to make an MR for this. I built a way for you to trigger a snapshot via the NATS event. So because I had to do it because I needed to replay it a bunch of times. But basically, Siphon has a snapshot ability. So Adam, do you want to explain the switch, how it switches?
Yeah, so Siphon works in a way that it has two mode of operations. So one is replicating the CDC data. So this is the logical replication part. So as changes happen to your data model tables, these changes will be sent to NATS and eventually to the downstream database. But in many cases, I would say most of the cases, you also want the existing data. And this is called the initial data snapshot, and Siphon takes care of this as well. So in a consistent way, it will take a snapshot of your tables and essentially move it to the downstream data store. So at the end of the day, you will have a consistent view of the data. There is one challenge. So let's say Siphon is up and running and it's replicating data to ClickHouse and it's perfectly accurate the data, but you want to add another subscriber, another database where you also need some of the tables that Siphon is replicating. And in this case, for that particular subscriber, let's say the Kuzu subscriber, you would need to trigger a special event that takes the initial snapshot for the selected tables and only sends the data to that Kuzu subscriber in order to not to overload the other subscribers. So there is a need for selective data sync to happen for a short period of time until the data in both subscriber, ClickHouse and Kuzu are completely up to date. And after that point, everybody can consume the same stream.
Are you saying that's not there yet, or that's something we can do?
So Angelo is, I think the initial steps have been made by Angelo, but this is totally doable. It's not done yet.
Okay.
Can you do this on a hot database, or do you have to shut down the clients for the database?
No, you can do it. You don't have to shut down anything. So this would just work on the Siphon level. So both databases should stay operational.
So if you're having transactions while you're doing the initial snapshot, those transactions will also be replayed later.
Yes.
Can you repeat it? Sorry.
So let's say you're doing this initial snapshot for Kuzu, and while you're doing the initial snapshot, like the main Postgres database is still receiving updates. Like, will you, after the snapshot is complete, like will these updates also be applied?
Yes.
Okay.
So we would buffer them. So from the downstream database point of view, you might get some duplicated messages, but essentially we are providing at least one delivery. And at the end of the day, things would be fully consistent. And this is all handled by Siphon.
Nice.
So are you thinking about using Siphon? Like, do you need just one Siphon consuming a one logical replication stream, or do you actually?
So
you have
yeah.
bigger,
So one Siphon can talk to one logical replication stream, and actually you can have multiple logical replication stream per PostgreSQL instance. So in case one stream is not enough to push all the data from the main database, you can scale it out. And the good thing is that nowadays you can create these logical replication slots on read-only replicas. So the primary is not really affected by this. And if you are looking at a multi-database setup like GitLab, you would need at least 3 Siphon producers that are connecting to one of them connecting to an individual like a database. So you need 3 Siphon instances for main, sec, and CI databases.
Yeah,
But you'd want to generally be quite spare. You know, you wouldn't want to drop in tons and tons of logical replications.
Yeah, I'm just thinking, you know, if you shipped a self-managed the GitLab.com, would you configure one logical replication stream for every database you need? And then if you had org mover, you had, you know,
I think ideally we should do that. But the downside is that, and correct me if I'm wrong, Adam, but my understanding is the downside is that if you need to rebuild any of them, you'll need to rebuild all of them. So I think that's the
Yeah.
Adam, is that correct?
It really depends on the downstream data model. So since we are requiring an at least once delivery, and in our case, ClickHouse database can deal with duplicated data because we are constantly deduplicating on the database engine level. Actually, if we, let's say, lose the replication slot in one database, you could just restart it from scratch, and eventually you would get consistent data without taking a snapshot from the other 2 databases. But
you know, you should actually really put in a thing that every now and again it just sends 5 of a message, like randomly, because we really want people to design their consumers to be idempotent in some way.
Yeah.
And just randomly, like once a day, it's going to send that message 10 times. Yeah.
I mean, that's what I was doing all the time for this.
Yeah. Because it's so important, like it'll cause so many problems down the line. if
Also,
those things are not
the
properly
table order
coded.
matters as well.
Yeah.
Like I have to do namespace first, and then projects first, and then or then memberships after that. Like if you do any other way, and your indexer needs the data, it'll
But surely you can't impose that on Siphon.
no, you can tell Siphon what tables to read from first, right, Adam?
But
yeah,
the order like on a rebuild.
you can tell Siphon which order to rebuild the data. So you can define the table order, but generally what you are talking about is the chicken and egg problem. So in some cases, Siphon breaks the transactional boundaries. So every table and changes to those tables will be separated by a stream. And there can be a case when, let's say, you create a project and quickly open an issue, and maybe the issue creation event will be picked up before the project creation event. And these cannot be handled by Siphon. This needs to be handled on the consumer level, either by this data lake idea, or you need a database that can automatically resolve these issues. So, for example, foreign keys would be a problem at some point, right? So if you replicate to Postgres, then foreign key constraint might be tricky.
I mean, it's a fair assumption that subscribers will need to be idempotent. Like, you know, they'll have to upsert.
Yeah. But as long as people are testing for that, and that's the
Agent wasn't forced to. Just
Oh, okay.
Stan, you wanted to show the binary breakdown too, right?
Yeah, that would be helpful because
this is so what I built. This is what I built.
2 more questions. One of them is like for idempotency, it's like Siphon providing like a stable transaction ID. Like if you want to implement idempotency downstream, you either have like perfect upsert and essentially hope that the upsert works out and you get the same state, or you have a stable transaction ID and the downstream system can check if that transaction has been applied.
Yeah, we can do that. So we can send the log sequence number with the events packages, and then in your consumer, you can build a wait mechanism. So don't insert a specific record until you get an event with that specific for smaller or higher LSM. I don't know exactly the logic, but with the log sequence number, you would probably be able to do it.
Even if we have the number only for debugging, it's super important to be able to trace, like, did I already see that update? It's the 5th time.
Yeah, exactly.
Yeah.
Second question, are we building I don't want to be boring, but are we building an IO cost model? Because it's in steady state, this has like huge write amplifications. You do one insert to Postgres, we're talking about like 5 or 7 downstream systems.
Yeah. You're talking about like the FinOps aspect of it? Where
for FinOps, we need to provide an actual like PD and S3 and whatever
Yeah.
storage we're using, IOPS model.
Yeah.
I mean, that's why we want to restrict the number of stateful databases we have anyway. Like,
Yeah.
I think most of this should just go to a single model into ClickHouse, and then most cases we should be able to query the same.
Yeah, but we have
Fair.
Elastic, ClickHouse, Kuso,
So
Zooked. Those are at least 4 downstreams that we know about. SpiceDB is 5. So we already know about 5 downstreams. I'm not saying we need to do it today. I'm just saying like we need to have
Yeah,
and
that's a good point.
the right amplification model because else this will explode in production.
well, I want to get how much this costs, what I have deployed. We can do estimates here as well.
Well, yeah, Michael's are concerned that every subscriber is going to cause an explosion of exponential costs, right? Like you,
Yeah.
it's not, you're just one consumer.
To add to our already growing GCP cost.
Yeah. I'm just recommending like before we even try to put this in production that we do like an envelope calculation. Like is this like doubling our IOPS? Is this like 10xing our IOPS? We should know that.
So probably not. Probably not. So Siphon batches up the changes, so you're not gonna get, let's say, an event for every inserts or updates. So every few seconds we batch up all the changes and put them into a package, compress them, and send it over the line. And the consumers usually have to do some kind of bulk operation to insert the data. So one insert in PostgreSQL does not necessarily mean one insert in ClickHouse or Kuzu. Ideally, things should be batched.
So does Siphon batch at the moment like on a timeout, like on a debounce type timeout?
Yeah.
Already?
Yeah.
Okay.
It's 3 seconds at this point. You can decrease it or increase it
nice.
depending how you want to. You can even control the packet size, compression levels. There are lots of tweaks we can do.
Yeah, but the downstream write coalescing really depends on the storage backend.
Yeah.
If you're calling a store and you're doing just perfect appends, yes, then you have write coalescing.
Yeah.
Yeah, and then the delete question comes too, right? Let's say I have a security vulnerability and I gotta delete some rows or something, right? A lot of the stuff is immutable, right? Like a lot of like analytic database you can't delete very easily.
Do we delete rows for invulnerability?
I mean, every now and then someone's like, "Oh my gosh, I put something in there. I gotta delete this request."
Yeah, because
Something like
people.
that, right?
I thought
Second step
when you
request.
press delete though on like an issue, it just marks it as deleted. It doesn't remove it from the database.
You delete
That's it. Yeah, eventually it does go away.
Yeah, like all the S3 based or like these like kind of blob store based storage systems usually write a deletion record in some transaction log, and then there's a replay process where the whole file gets replayed and the deleted entries drop, but they're not dropped immediately. So you have twice the write. You're writing the deletion entry into some log, and then you need to do like a weekly or daily replay of the file.
So Postgres is like this. We delete item is still there until the
vacuuming.
Do we have a model for like what we're going to put it? Like I'm talking more about ClickHouse now, but like presumably we're not just going to replicate the entire LTB database into there, right? There are things that we are going to transfer across, and there are things that we won't transfer across. Are we just going to do that ad hoc, or do we have like a model for thinking about what should go across and what doesn't?
Yeah, we
I'll share the link.
We can't. I'll possibly just throw
That's why I think like I would prefer to leverage partner with data insights so we can like make it very clear what data model we need, right? And then when you have multiple consumers consuming from that same service, you'll be able to have people be like, hey, no, actually we should do this, or it should look like this.
It shouldn't just be
Rather just one
just be
team
default,
doing it, right?
Okay.
I shared in the document our current ClickHouse data model.
Where are you putting that?
It's in the agenda doc.
Okay.
Thanks, Adam.
You gotta go to
Okay, so compared to the LTB one, that's relatively small right now.
So this is basically issues and merge requests and the satellite tables. On the left side, you see siphon underscore tables. Those are essentially the one-to-one mapping between PostgreSQL and ClickHouse. And on the right
But you
side,
don't
you
have-
see, yes,
You don't have comments or it's kind of all metadata, right? Or is there?
we have comments.
You
You
have
mean the
Oh, the notes.
Notes
right.
table?
Yeah, okay.
yeah, notes is there, yeah. So left side, it's basically replicated directly from PostgreSQL, and the right side, usually you see the MV, materialized views. So you have merge requests and issues, and these are these super tables that are containing a lot of
why I
denormalized
think,
data.
that's why I really like this solution, because this is something Elasticsearch and correct me if I'm wrong, Dimitri, but like this is something Elasticsearch and Zoic could use too for the traversal paths, because it has the traversal path baked into it. And that's super important for security. That's what Knowledge Graph would need,
Yeah.
rather than doing the logic at application runtime, right?
But I mean that those change too, right? How do you keep that fresh?
Yeah.
That's true. This is
Comment on that?
yeah. If someone changes like a developer to maintainer,
Yeah.
or
Yeah.
downgrades actually from maintainer to so
Well,
there's replication lag.
I have a dumb question. Like, what is a traversal path and why it's a string?
That's an optimization for ClickHouse. So essentially, it's traversal IDs, the same array that you have in the database, but we also prepend the organization ID, so we can do organizational level queries. And it's a string because ClickHouse is better matching strings, so it's actually delimited by a slash.
yeah, and Dimitri wrote this really good article here on namespaces and why like we need that type of string. It essentially cuts the amount of data you traverse. Yep. It's like this is like probably core concept to GitLab.
And if you move a project, does it mean?
Huh?
I'm not sure if it was me. Tried it.
And what happens if a project or namespace gets transferred? Like, do we need to update?
I think this updates. There's like I saw a Postgres recursive query or something. It runs and it literally updates the traversal.
Yeah, so Postgres does it, but then all the downstream consumers, how do they deal with that?
Yeah, how do they do?
They would get a change from the namespace table. And you just update. So
Do you update those things very usually? Like, do you just do bulk insert of all the namespaces?
for the what I'm using Delta Lake. I didn't try ClickHouse. Adam
Yeah.
can comment on a ClickHouse, but on Delta Lake it has the merge ability. So all the data that's coming in, I literally just it checks and merges the latest one.
I got it.
actually.
Okay, so you have an update. You have a way to update.
If you move an org from GitLab org to GitLab org 123, it'll update the namespace table, and that table record will propagate through, and you can update the downstream data.
That's good.
Why not using like a stable identifier?
Sorry.
You mean like a mapping of like the same traversal IDs to?
I mean, like now you like do a slash on like a path, like, but instead of using path, you would just use ID, like, which is stable regardless.
Because when you
Wait.
transfer a namespace, like
Okay,
the path is
it's gonna break as well. But like,
This is triggering another discussion to table, like when are we going to start slapping in UUID v7 on each of each entity that we have?
No.
no one is able to answer the question.
once
Who's gonna do it?
once we have source in another database that is small enough to experiment with.
We
Because like doing that on the current big database, it's gonna be disaster.
I think that
And that's the nice thing, like migrate between cells. You can do transformation of the data as well, and like remapping to the new structure as well. So a lot of these like transformation on UID could be easier.
yeah, I just wanted to say that the first time we discussed UUIDs was, I don't know, 10 years ago at least.
Yeah, but 10 years ago, UIDs had severe problems like index casting.
Yeah, we do.
Yeah, but with UUID v7, you have
Yeah.
index friendly UUIDs,
Yeah.
and you don't need to
Less
test it.
collision. Yeah, and the last time we discussed this one when we introduced the AI internal IDs for pipelines. I remember that was a huge problem, causing some contention. We discussed this in Crete.
That's so long ago. The world has changed.
Sorry for the off topic.
I mean, coming back to the authorization problem, like if you've got a lag between the authorization rules, that's a problem, right? Like if you got a lag between the authorization rules actually getting replicated here.
Sorry, Shaker.
Yeah.
My understanding was that there was that layer 3, where it goes back to Rails or in future something else.
Oh, so the
And it does that's like all optimization for kind of chopping down the amount of data. But
Yeah.
you always want to have the layer 3, which is effectively for each returned row.
yes. I thought the
Well-
layers are just adding query, like the where clauses on the query.
No, no.
No,
So
You said the last layer actually pulls out results directly.
are you going back to the knowledge graph design? Yeah. So let me
Yeah.
go back.
but I feel we have to.
But
do
then to
something
your
like that.
point, eventually we were talking about using SpiceDB as our third layer.
That should
but
be the
that's a-
redaction
that's
layer.
a-
That's what I talked with.
Long way away.
That's
Well,
what I
it's not a long
talked.
way away, but it's the future.
That's what I would talk talked with Mo about. So this is so that we would segment first, right?
Mhm.
And you would build the traversal IDs at comp time, right? So your data ingestion, your ETL layer, right? So each issue merger class will have the traversal IDs, right? And then, man, I can't believe I wrote all this last night. And then the final redaction layer. Which will, so the beauty of the cipher, I don't know if we'd be able to do this to answer the question on ClickHouse versus other ones. I mean, maybe we could, but you have to always have return to make that agent traversal possible. You always have to return the node in the response, and then you would take the node and ID and type and check against the database.
So where to do that for advanced search?
Yeah.
Yeah.
Did we do this for you? Is it?
And what is a resource?
So did you say
Like, that's
you already do this for fun?
Yeah, for Elastic. Yeah.
Okay, so it does the
That's another dumb question. What is a resource? Is that like, does it correspond with what we store in tables in the PostgreSQL?
Yeah, so it'd be like issue. So that's the data model part. Okay, so you're getting in the data model. So I wrote up what the data model looks like and what I built basically for the SDLC knowledge graph. So first of all, this is representation of GitLab, right? So you guys saw that when we were looking at it live, but like this is kind of what GitLab is. It's a network graph. And this MR can relate to this MR, and this MR.
I understand that, but if I wanted to compile a list of all of the resources in GitLab on which we can check access or like evaluate access authorization decision for, how would I build that list today? Is that like going to the PostgreSQL and listing tables created by Active Record?
I see. Yeah. So we would at least Dimitri and I are talking. We just basically make an endpoint. It would take thing of an array of objects. It would have the ID and the resource type, and then we'd have to build that out manually. That's the downside of not having an auth service, right? But we would we're adding the issue type. We would be able to support that via that endpoint. And so when the final thing is returned to the user, or before it's returned to the user, it would go hit that endpoint in Rails, and it would just run through the current Rails auth logic.
So for example, a pipeline duration is not a resource, but the pipeline is a resource, right? Like
Yes. Yeah. Yeah. Oh, when we build the graph though, it will make sure that that is part of
and is that what we want to have like long term? Because I guess that we might want to build some governance around data access, and the pipeline resource might actually have some attributes which might be accessible to some people or might not. Anyways, maybe that's not for this conversation about knowledge graph, more about authorization. But anyways, I think we should probably build a catalog of resources.
No, that's a good point.
Do we want to take a 5-10 minute break?
Yeah.
Maybe an air, bathroom.
Yes, it
Well, that-
feels super warm.
Yeah, I know.
Something like.
Okay, box one, right?
Alright.
Yeah, I guess we can just pick up.
Hurry up and finish the job.
Oh, wait, let's go. Let's talk about the binary.
All right.
Enter something that's going to
You guys all have a break? Everyone got a lunch card?
like this,
Which is perfect.
you know, I think this is.
So we're just gonna pick up a little bit about how everything's sort of laid out right now, so. Why don't you go ahead?
So yeah. So I think something that would help the knowledge graph team by the end of the week is getting some direction on like where we should go in an iterative way. I think we talked about going maybe with the Zoic approach first for code indexing. I do not think, I mean, let me know if you guys disagree, Dimitri or Omar, but I do not think we should go with the Zoic approach for SDLC indexing. I think we should go with the data insights approach. I would say maybe like my question is maybe we can figure out a path forward with the data insights approach. And if we can do that, what's the estimated work amount? I talked to Adam. Adam said that Siphon has been tested with high volume data, but it hasn't, there's been no infrastructure resource allocation on like getting it shipped to prod, but they want to. So it just, I guess, is up to business priorities. So I guess that would be kind of like an ask from leadership. But hopefully at the end of the week, we can have a path forward. And so this is like the proposal of, I think the indexing part, I think we covered the query architecture, but I want to like go into what this looks, what I built, and then maybe say, pick what we like and what we don't like, what can be consolidated and whatnot. So I broke it down. Stan and I were talking, and we figured it might be helpful, especially delivery wise, to talk about like what are the various binaries that would be involved and what you guys saw today with the demo. And so we have logical replication, right? We talked about this. We would have the Go binary for Siphon. And I think they build for both consumers and producers with Siphon. We also have NATS, which is also a Go binary. And then we would have the knowledge graph, which would be a Rust binary. We could also look into making the SDLC part of knowledge graph a Go binary and transferring all the code indexing resolution logic. That's something we can explore more, but this would also all be a single binary. So the indexer and web server, this applies to both Zoic architecture and this new architecture, which leverages data insights. It would be serving the indexer and the web server would be a single binary. One nice thing, I don't know if I was talking to you about this, Stan, but we have this binary built for all major OS today. I don't know if that helps delivery wise, but
Probably not as much as you think.
okay.
Yeah. I mean, Jason would be the person to answer that, but I would say probably not because they've got all their own
Infrastructure for, yeah, I would love to,
and
that's what
yeah.
I want to know.
I mean, like,
Yeah.
there's a whole discussion around that because
I think that'll be really helpful for us to.
wait.
Okay.
So it also, if we just doing containerized and service self-managed
CNG
advanced
version, yeah.
and not having omnibus, that obviously changes it a little bit as well. Not totally. It doesn't.
Yeah.
It's not just hey, we build a container and we're done.
Yeah.
But yeah.
And then the last thing is ClickHouse. If we use ClickHouse as a data lake, I put two options. So the first option is ClickHouse as the data lake. I haven't experimented with that because for the essence of time, I just didn't want to set up ClickHouse and put all the tables through that. It's like a lot of work. So there's the option of one, I talked about this with Nitin. He said, either way, you need a data lake for the knowledge graph to query from. Like, you can't, we don't want to do a streaming knowledge graph yet. That'll just be too much. Trust me, when I built the namespace indexing algorithm, it's just a lot of work if you want to make it streaming in real time. So we need a place to query. My proposal is basically to use ClickHouse as that, or some type of object storage. So what I built was using Delta Lake. So if you guys have this document open, also how much battery do you guys have? Okay, I'm good. I like to live on the edge here. Let me go down. If you guys go to this hybrid architecture experiment, throughout the day, it'd be great if you guys could read this, or throughout the week, because this outlines everything that I built. Wow, of course there's an error. Everything that I built the past week and a half on like the actual GKG cluster. So I didn't go through CNG because I figured that would be too much. I literally just I created an entirely new cluster config for the entire deployment. But going back to the binaries, I figured it'd be helpful to break down what the architecture looks like by binary. So for delivery purposes, we can kind of look at what that looks like. And any of the gotchas.
Why is the knowledge graph queries data? Sorry, it doesn't write. Sorry, never mind.
Yeah, and so
And the PD there, this is like either Kusu or Filecore or something, or what is the format on the persistent?
yeah, persistent disk. This is assuming we do Kuzu. Now, if we pick a different graph database, that might look different, right? But I have it writing to a PVC. So the ClickHouse server, the two options that I have for that is, again, ClickHouse option 1. Option 2, we can also look into it if we want, and that's dumping the data. I know either the analytics team or the data team, someone needs to help me understand the difference between the two. The people who are doing, I think, the Snowflake, they're thinking about exporting to S3 somewhere. Someone told me about that. I think Adam told me about that. But either way, what's happening today, you can see there's no ClickHouse in my workloads here, right? So what's happening today is it goes through Siphon, and it goes through Siphon, goes through NATS, and then I use this technology called Delta Lake.
We can't use Delta Lake in GitLab, right?
Sorry?
We can't use Delta Lake with the application.
Sorry, what do you mean?
Like Delta Lake it's not something we can basically ask our customers to deploy.
No, so at Delta Lake is as long as you have S3 compatible object storage, or PVC or anything, something that you can write to disk, you can have Delta Lake.
Yeah, but we've already, this goes back to the same discussion as we've kind of selected ClickHouse as that analytical thing.
Yeah.
And we don't want to kind of put
we don't want two more.
We've kind of gone through that decision multiple times, and we've kind of landed with ClickHouse.
Okay.
I think Sid made that decision really before anyone else had much say in it. But ClickHouse is where that is. So I don't think we want to add more
more
warehouses, right?
Yeah. So that's why I put ClickHouse as option 1.
Yeah. Very much.
And yeah, so that's kind of the binary breakdown of what would need to be shipped under this this architecture.
You all mentioned like Zook, like hooking into Zook. I don't see any of that here yet. Is it supposed to be?
So this would be like the future state. The Zook architecture would be like what we would do to get code indexing out, but it would only be for code indexing, and it would just be plugging into the Zook architecture. Part of my question is should we put effort into that, or should we go all in on this as well? That would be one question.
I mean, can you build the code indexing into the same pipeline? Because that would be
code indexing will work with this architecture as well. So
so you don't need the Zoot architecture for coding. Like you can rely on this architecture with the
for both code indexing and
exactly.
SDLC and
so
yes.
Yeah.
I mean, why Zook? Because we already have the functionality of pulling code from GitLab. That's already in the Zook. That's why we wanted to reuse the Zook binary because it's already like pulling code and just dealing with investment, and that's why we thought we can use it for it. So even if you do something like this, but I cannot see everything, we need to at some point something to pull code from, probably in the Rust.
So I already, what you saw there, I already wrote all the code, the Rust code, and I figured out some bugs that we would have hit either way in production. Gitaly has what is it, HCE, HMAC signing? I forget the security, some type of header. You need some type of special header, and it took me like 3 hours to figure out what that was. It was like not able to authorize with Gitaly, and then I got it working. So what you see in the demo.
So you're making direct gRPC calls
Yes.
to Gitaly?
Yeah, I'm making direct
But you have
gRPC
to-
calls to Gitaly with the code projects. So if you go to any of these code graphs, this is indexed and it runs through that same pipeline. There's a lot of nuance in here, but it runs through the same pipeline. And when it runs the code indexing, it fetches via gRPC straight to Gitaly. That's what happens with Zoic today, but I just wrote the Rust version of that. So that's all already working. I mean, we'd have to push the code through, but
I mean, it's kind of nice that single indexer just can do everything it needs to, right? I mean,
Yeah, I mean, the Zook index doesn't go, right? So we'll have to jump from Rust to.
well, I think that's the issue that they're.
so the current architecture would be basically Go would call Gitaly and send the data via HTTP or on disk.
Yeah.
For
Or Unix.
and that's another layer that I don't know if I necessarily like. Versus
simplify the.
we want to call from Rust anyways, right? Like eventually, but the current way that we would do it, like what's currently scheduled, we would pass it through Go.
Do you see any reason why we should stick to the Zook architecture for the code indexing?
So I think we can ship it much faster, but because of being archived, there is a big range into this plan. Maybe if we choose another file-based database, we can still
Depends on what you're using.
But I think the speed is the main benefit. We can ship something maybe in
Yeah, that's the-
summer too.
Yeah.
Zook is still using Siphon and Nuts, so
No, Zook
Zook
is
is
using just Postgres and the cluster.
this is a lot of time saved in delivering all those things, right? I have to check, but I don't think we have self-managed ready for any of those things.
No, none of them.
For Zook?
No, I mean for Siphon.
No, we do not.
No,
But that's part of the ask here is to see, can we do that?
We-
It's
we were
ambitious,
planning to
but
do
can we
anyway,
do that?
So
wasn't that already?
If we want to do so.
So once, if we go down the self-manage and we get the oak and there's a lot of things that need to be done, but like that's what we're trying to speed up.
Okay.
Trying to
But
make
at least
it
I know from leadership perspective, when I talk to Tim, Mitten, and others, and when I talk to you, you and Fabian, the plan is let's get it to .com, right? So
Yeah.
my question is,
We've got a whole session on that after lunch.
can we do
Explain.
Siphon, get that to .com?
Yeah,
Because
that's-
Adam
that's
said
being
you
done-
can
that's
get
being
that
done
to
at the
1 and
moment.
3 milestones.
Yeah,
so
that's being done right
true.
now.
But if it's true that we can get Siphon in 1 to 3 milestones, then in parallel we can build all this.
The thing at the moment is .com is a very different beast from
Self-managed.
self-managed.
Yeah.
And self-managed, there's a lot of complication about how we need to get there that we don't fully yet understand. Like .com, we can deliver stuff to .com very easily.
Okay. I think the main thing is they want something deployed at some point. but
The problem is that
that most of our
then-
revenue comes
then,
from stuff.
the customers say, we see this on .com, why don't we have it in dedicated? Why don't we have it in,
I heard that's the case for the registry right now.
the registry is in, but we currently don't have the database. So we don't have the new.
That's what Sam told me.
The
or something.
garbage collection for.
Yeah.
Inline garbage collection.
Yeah.
But
Um,
there is no high demand. That's the last thing I was reading, that seems that self-managed customers are not willing to do the migration.
Hmm.
Because it's maybe they have small instances, they just keep the storage and they don't want to do the manual work for doing the migration.
Yeah.
So there's this
Yeah. but
keeping
this-
two things supported for a long time and trying to figure out how to force
This
gentle
this
migration.
ties into a lot of the discussion, right? Around like, if you're going to be introducing a lot of services, like customers are going to push back at some point, right? If you
Yeah.
if every month you say, okay, before you can upgrade, you need to do this, this, and this, and you need to provision a new this and make sure you got like those are the things. Just as a general context setting here, that's the stuff that we've got to be cognizant of, because one of the things that we're also getting told is, customers are upgrading less and less often because it's getting more and more difficult.
complicated.
And so if we keep saying every month, hey, we've got these 3 new databases, you better make sure that you've got like run books for backups for the way that you've done it.
Right.
That lag is going to get longer and longer.
Is there a way we can make that more turnkey though?
Well, that's what Runway is. Runway for self-managed is that turnkey.
Is that turnkey? So is that the
Yes.
plan for OAK or something? Or
Well, Oak is where you run.
It's a separate conversation. I think we should get there when we get
Okay.
there.
okay, sorry guys.
That's all
I
scheduled.
think the good thing is over the next few sessions, like I think we will come to the agreement on what are the services we need to deliver in the next few.
Well, I mean, from this perspective, I see, obviously we're talking about ClickHouse having that up and running.
Yeah.
Siphon, Nats, and to me, this is right now just a binary that you connect to these other things.
The only new thing
So-
here is essentially knowledge graph. If we
Sure,
Like-
but it's not
Other
not
than
really a
the-
service per se. It's just like a thing that needs to connect to these other
yes,
services, right?
Yeah.
Like,
Yeah, but do you want to talk about whether there's a replacement for Kuzu? Because it kind of feels like there's a lot of things that will be reliant on what
Yes.
that technology is, and if it's not Kuzu, then it might change things.
Yeah, we're looking at a few databases. It also depends on like what do you guys think would be the pain tolerance for different databases? If we need something that's going to be not file based, does that throw a wrench into things?
So how bad is the Postgres extension? I forgot its name.
Yeah, that was
Apache
like,
8,
Yeah.
Apache 8, right? So I mean, Dimitri actually did the analysis of Apache 8 on.
That wasn't.
So that,
that was PG. That
they haven't had a commit in 6 months.
Haven't had it?
They haven't had a commit in 6 months, and the performance was not good.
Who did that?
We did benchmarking at the company. I didn't do that. I think Kian, who left
Yeah.
for the,
Yeah.
I think he was involved in some benchmarking. I don't have the link. I can look it up.
I got it.
But there was some benchmarking, and then like we thought, okay, no,
If it's not a
it was not good.
Because my big worry is if you select something kind of new, like what's happened with Kuzu could happen with something else. And
Yes.
the other big risk is license change risk with all these new, as people kind of jump in, they're very excited, and then they realize, oh, we're actually not making any money out of this, and everyone's using it. Okay, let's change the license. And I think that was always something I was worried about with Kuzu, but actually.
Kuzu just nuked
Yeah, they just deprecated, but it's the same thing.
I'm a little
right?
bit
Like,
mad about that, guys.
yeah. So how, like, what do we do for that?
And I think that's part of the criteria for database selection because honestly, it's like the graph databases, I think the only one that's been around for a long time is Neo4j, right? And
What
the other ones are
license is
all
that?
Sorry.
The only one's been around for a while is Neo4j, right? Now
Yes.
the other open source ones are still in rapid development and they may die out.
We would definitely have to make it very clear.
It feels
that-
really early to choose a graph
Yeah.
database
Yeah.
at this point. It almost feels like we need a way to say this is an alpha project that we prove
Yeah.
out and then we graduate it to like
Actually, there are a few
Over
other
time?
databases. There's Janus Graph, I've heard, but that's not Cipher.
but I'm sure as you
Yeah.
run in production, you're gonna find issues with it.
With the database,
Either with
yes.
monitoring, some bugs, right? There's gonna be some maturity process. And I don't think we can subject all our customers to this like alpha. I mean, all these databases are alpha or maybe beta at best, right?
Yeah. What about if we just said you need a Cipher compatible database, knowledge data? So I'm thinking with my dedicated hat on. Dedicated really likes to run managed services and because it
Yeah.
scales better. And I don't know if Neptune
Yeah,
is
Neptune.
compatible with.
No. So that's the main
Yeah.
approach the team took, is
Yeah.
because we knew Kuzu it's not like Postgres, right?
Yeah.
There's not millions of commits to it.
Yeah.
So we saw though that Open Cipher is a thing. And so as long as it supports open cipher, we
What is
wrote our.
Open Cipher compared to Cipher?
It's like answering.
It's like
SQL.
Okay,
Yeah.
right. I didn't realize that Cipher wasn't that already.
Yeah, so and I think OpenCipher was spearheaded by Neo4j. But the way we wrote the indexing logic is all the indexing logic happens at compile time.
Yeah.
Like it happens outside of the database. We don't do any merge queries or anything. It's literally we build the graph and then we bulk insert into Kuzu.
Okay.
So as long as the database supports that, or Cipher, then we should be okay theoretically.
I mean, even within SQL, there's different flavors, right?
Yeah.
Like,
Yeah.
PostgreSQL doesn't quite work.
There's gonna be
MySQL,
quirks for sure.
right? So, and especially with graph query languages, I'm sure those are in flux too, right?
Yeah.
How like this comes down to like how many self-managed, because this is going to be mostly cloud self-managed customers. Like, okay, we can just spin up Neo4j or Neptune or whatever else,
But
right?
yeah,
But
but Cipher's only the query part of it, right? You've still got to write to that database.
Yeah,
And
yeah,
that's kind of the tricky part.
yeah, exactly.
Yeah, we would have
Each
to
one
make
has their
some
own-
adapters
Yeah,
essentially
right.
for
In
Okay.
general, like I do wonder whether we have to talk about that, like, and this isn't for now, I don't want to hijack the conversation, but in general, you know, like with the analytics database, like would it have made more sense to make that adaptable so that people could kind of plug into, if they're using Snowflake already, would that have been an easier way for us? And then maybe also with Nats, you know, there was talk
Yeah,
about
PubSub.
people that already got like a PubSub interface in their thing, could we use that?
I will just remind us that we're currently only testing with all feature flags on, because we cannot test with like various combinations of feature flags. If we allow different storage systems, I'm just saying this out loud, like we will never be able to test with all combinations of all storage systems.
That's, but you know, we're still not delivering things very quickly as it is right now, right? So yeah.
Can we look at the performance of Apache H? Like, was this like a 2x? What was it, 2x slow or was it exponentially slow?
Yeah.
it's I think it was more on the exponential side. Somewhere in here.
Because exponential cannot be fixed. Like we can buy our way out of 2x, but not out of exponential.
Makes sense.
And does
Yeah,
our
they would
conversation
start hit.
around-
Look, so this is what Jan said. We would start hitting the issue with just 1 million nodes and edges, or 4 million nodes, 1 to 4 million nodes and edges.
But it
And that's just not. There's no way we can do that with GitLab data.
It's just based on Postgres, basically.
Yeah. It's a Postgres extension.
Yeah. Probably.
Also, then we require customers install.
And Age is not one of those where you can just go to Cloud SQL and say enable Age or something. It's not one of those.
It's not one of the.
Yeah, it's common.
Oh, is it not?
No.
It's not naked, bro.
Ma, you brought up SpiceDB, and does our conversations around database technology for graph databases play into that? Because I see that you have like it's Postgres, but is it Postgres?
So what SpiceDB is doing is SpiceDB has its own schema language. So
Okay.
SpiceDB is essentially an open source implementation of Zanzibar. Zanzibar is the authorization system that we built for G+. And what they're doing in SpiceDB, the authorization schema in their own schema language, and then they're transpiling that into a Postgres schema. So you can in the database you can kind of see your authorizations, but it's not. It's like essentially transpiled. So SpiceDB as a binary is stateless, and everything is in Postgres or in Spanner or whichever backend you're choosing.
Are you gonna put it in prod Postgres or no?
No.
Should you do a copy Postgres or a new Postgres?
So it would either be a different Postgres like physical database, or it would be a SaaS service like Planetscape, or it would be Spanner.
Okay, so customer would have to also set up another Postgres.
Yeah, but on the customer side, it can be a logical database in the existing Postgres cluster. It does not need to be.
Okay, a new.
I think it's a measure of security. You want to build more boundaries, but
Yeah.
customers may have
That makes
different risk tolerance or different
Exactly.
different threat model. And
But the default kind of omnibus setup would be like in the same physical database, we just create different logical.
As soon as we have that, I'll make the knowledge graph really, really nice because then we could theoretically translate those permissions to. John, you had a really good idea, right?
Well, what I was questioning was with SpiceDB, what does our query strategy look like? Are we using a traditional graph query language for that, or or are we just writing SQL?
It's more like a policy type.
Yeah.
No, it's
all
It's not, I think you talk in like Spice TV's own language, right?
So
You know-
SpiceDB is just exposing gRPC.
Okay,
You are providing like resource principle, like
Yeah,
Okay.
like a policy type of.
just that gives you an answer.
Okay, I
Internally-
wasn't sure if there was a combination where we could essentially write a query that gets that combines our graph databases in a way that we can automatically get authenticated resources from a single query, rather than needing to have some kind of like, okay, we have right now we have 3 layers of authentication. And at the very end, we go, hey, here's a whole list of resources. Can we get back which resources I actually have access to? Is there a way to optimize that flow a bit? And the reason I was saying Neo4j has the concept of I'm more familiar with like RDF style databases like Quad, where you say, hey, here's a graph, and I'm going to query from that particular graph, but I'm going to combine it with the other quads, other graphs, and being able to query across databases is going to be something I think we're going to very quickly be interested in. So not just SDLC, but also, I'm interested in what's happening in my code across branches, or what's happening in even pointing to I'm interested in a graph that's the resource is my local repository. So I just think we have to think about that from a query language perspective as well.
There are a few solutions to this. So one solution. So the original, I'm just sharing a little bit, like the way that the original G+ and Workspace and so on are doing this is that you call into their indexing systems, and the indexing system itself would then call out into SpiceDB on the backend, and would, before returning the object, would already determine whether this user has access. And there's super heavy caching inside of the authorization layer, because you're essentially going into the search tree. You have like 10,000 replicas, and then 10,000 replicas ask the authorization system in the same millisecond the same question. This is one strategy. The second strategy is that you're doing essentially fine-grained authorization by linking the authorization library into the graph database. Yeah, so if you want to have really high performance, you need to link the SpiceDB client into the graph database, and as you're sending the response from the graph database, already use the heavily cached in-memory in Go, in Rust, policy decision points. That would be the second.
That's typical. That's what I've seen done in other organizations is, and I've heard it called like NGAP, or like next generation access control.
Yeah. It was in GCP, it was called FGAP, fine-grained access control.
Yeah. And I found like really good performance, because I think that typically that authentication becomes a bottleneck if you're like really looking for real quick results.
Yes.
So
Also, it seems to me we got to do a little more work offline.
Yeah, to figure out,
There's a
yeah.
GraphQL, graph database that actually
yeah.
is production ready, which I'm kind of skeptical it is. Like any database that hasn't been around for 5-10 years probably isn't quite production ready, but we'll see. Maybe there is something out there.
I mean, there's this thing called Puppy Graph, which converts from
That's not even open source.
a cipher to like.
Not open source.
That's not open source. No.
It's got its Puppy Graph Python.
And I
If you go wrong.
Puppy grab, it's probably still growing up.
yeah.
But also the solution could be like you anticipate that this is not your end goal, and you maybe keep writing to many databases. The same.
Yeah.
We could also take the approach of, just saying it's very experimental. Just knowing that we'll swap out a better database at some point.
I don't know if we want to go to like self-managed. Like I can get that on SaaS, but I don't know if you want to go all the way down to self-managed with that.
Yeah.
I mean, it'd be nice to at least have the components like Siphon and all that stuff hooked up, and so when you're ready to
I mean,
go.
what if we just roll out different different consumers? So you've got this GKG ingester thing, right? The indexer.
Yeah.
And what if you just have an indexer Neptune, indexer
Yeah.
Pluggable.
you know,
pluggable.
yeah,
It's
so
very much possible.
yeah, and so self-managed customers
Yeah.
just bring their own, and then
Yeah.
as long as the database is Cypher compatible, you
I mean, it goes back to the
like testing. That's a testing nightmare. Like telling the car, like Cypher is super obscure with apologies.
Yeah.
Like for the random sysadmin, if you ask them, I need a Cypher, they know,
Yeah.
they know where it is, and then they know MySQL, and maybe they know Postgres. So if
Yeah.
you say like I want a Cypher compatible ground database,
Totally.
they will just
And then like just testing compatibility is a nightmare too. We had trouble just supporting MySQL for a long time.
Yeah.
Try to imagine like, oh, we should do Neptune, Neo4j, and Kazoo, right? Like
Yeah.
it's just a nightmare.
I would rather ship Kuso now because it already works. And then have a migration path where we're adding a second indexer on self-managed, and then the customer run the second index. And then we garbage collect the Kuso databases. Rather than waiting 5 years until we have a different database.
Yes.
For my worry there is like for self-managed, it's not like within the abstraction of GitLab because it's data and it's something that the admins want to know how to back up and restore and so if it was something that was perfectly encapsulated within the application, like I'm all for it. But like those things, they want to know how to.
What do you mean
by
stable, mature,
Yeah.
right? All those things, right?
Yeah.
Like
And for stateless stuff, it's different, right? Like stateless stuff is
Absolutely.
But this is
The
only
design of this is supposed to be stateless
Yeah,
in a way.
this is only derived information.
Yeah.
We're not using Kuso as a source of truth. Right?
Yes.
Yeah, maybe
That's why
instead it is that.
That's why the proposal is saying this is OLAP. It's not OLTP.
so can we ship with Qzo, right? They've archived the project.
I mean, you can. They just released They did a release, said we fixed a bunch of bugs. Sorry, we're building something new, and haven't said a word in Discord. Nothing. They're
Really?
completely ghost. Everybody's asking like, what happened?
started to come.
I asked like, hey, what's
Yeah,
going on?
They got funding.
They got a lot of money from somebody.
At least they solved the bugs, so.
Yeah. Well,
They're like, let's rewrite the C++ random code. And
go back to ownership. Like, let's say you ship this thing, right? Are you gonna own the whole end to end, like Kazoo?
Yeah, what's the business model?
Yeah, I don't know. Like,
The question is if we ship code indexing with Kuso in the beginning, because we are so close for that now. Honestly, even with the service architecture, is it going to answer some questions? Is it going to help us discover like, okay, maybe we should invest in graph databases? Maybe we discover some problems somewhere else, not in the graph database, maybe somewhere in the. So since we are so close with that, with the code indexing, of course, like if there's priority for SDLC data, that's a different story. But yeah, like maybe there's some unknown problems that we don't know.
Wait, shipping something that we know we're going to deprecate in the next 6 months or something is painful.
But that if we deprecate, we are not going to deprecate like everything. Probably like only the graph layer, and the knowledge graph Rust code is only written in a way that the database can be replaced by something else because it's like active record. We can rewrite. We can write some adapter for another graph database.
That's the way we wrote the logic. We didn't. So when
Or
Probably for a few projects, like with a feature flag enabled for.
but like it's like limited to a GitLab.com.
I think so. Yeah. Not.
I'm
not
like,
necessarily-
ship like one,
not-
So like
The vulnerability
even if
even.
it's a
Yeah.
and every other aspect of the integration.
the only way to be step one is to combine the databases, but we would make sure the
Because we
data
can
is.
figure the index.
No, but if there's
I
a
have one conversation.
I'm sorry.
Sorry.
Unlock.
Which one?
So my thinking, like even if you are deprecating that in the 6 to 12 months, rather longer than a year, it's completely fine if you are shipping that on the GitLab.com because it allows you to validate every other aspect of the system. And as long as you can replace Kuso with something different, If you don't have customer data on it, it's completely fine, but like you kind of can concurrently work on another adapter, basically. Another service, another graph database.
Yeah, that's that. But because also at some point, for example, if you want to change the schema of the and also this happens with Zook, like everything like we are discussing happened with Zook as well. We trigger all this re-indexing. So imagine like we replace Kuzo with some other database. We just trigger re-indexing for everything, and the whole code base is gonna be re-indexed again. But in the meanwhile, like while Kuzo is still somehow like there was some bugs fixed recently, so maybe we can still validate that approach until later we can trigger re-indexing on any other database or Neo4j or Postgres as a graph. I don't know, like so yeah.
Yeah, I mean, in an ideal world, we have a Helm chart that we just say deploy this thing and
Yeah.
connect it, and then we test it out with internal projects for a while and see how it goes and validate that this thing is useful, and then when it's ready, we just you can do a better product proposition, but I wouldn't ship it to self-manage right now until we feel good about like where it is, right?
Yeah, that's the plan, at least, was get it to .com first. Not self-manage.
And I mean, there's like from a wider business point of view, it also makes sense to get it to .com because we can get that feedback, we can understand how users are using it, iterate quickly, and then kind of once we've got the better product market fit, then you go to self-managed, right? And we don't have that same observability in self-managed, so you don't know what customers are doing there.
I do know it's a product priority to do SDLC though. Probably maybe even over code index.
No, really.
So what is the plan if we go with Cruzu and CV gets out?
That's it.
Do we have expertise in the company that can actually fix
CV in Kuzu or
That is my point. Like that is the big thing. There's one on like a big 0-day vulnerability. How do we patch it?
I mean, if it's still experimental, you shut it down.
Yeah,
But it has to be clear because
not great.
what I'm afraid here is this, right? That we say, oh, we can go to .com very fast, very quickly. We do it. Then we have, I don't know, some executive that just blog about it. Yeah, this is super cool. It's coming in 2 milestones. Right. And we know this is not true, right? So is this interlocked? Can we make it clear that because of these reasons, right? So the underlying engine being unmaintained and things like that, we are just doing exploratory work, and we have to be very clear about this cannot be GA for a long time, maybe, right?
I think we just labeled alpha. We had definition of alpha very clear, right? And it should not graduate from alpha for a long time until we are confident that
It can stop working at any time.
But if you ship something Kuzo or whatever for code indexing, whatever, we should have questions in mind before which questions we want to answer. Like, okay, we want to deploy this. Our customers are using these tools, or they are like LLMs. It's not even like calling these tools. So we should have some numbers or something to know, okay, this is useful or not.
Part of the pitch as well is to maybe even think about making an API like that can be used outside of DApp. So it integrate with DApp, but you could, I know that there is interest in basically charging even for usage on the API.
Yeah.
Which is a whole other thing. But
So how's the API look like? Do you allow arbitrary queries or?
No, so I can show you guys.
Does that answer the CV question? Like, do we allow the user to somehow send handcrafted queries? Then you can take the query engine.
No. So this is how the indexing side. If let's say we go with Kuzu, the database will be a file for only the top level namespace. So the only way for customers' data to leak is if we have a bug in the indexer and we mix match the customer data, right? That's on the indexing side.
This SDLC.
SDLC. I'm talking about SDLC. Now, on the query side,
and we assume that there's no way that while you're indexing that, I'm not saying like
drafting an issue that will inject.
I'm not saying SQL injection effect, but you essentially cannot like escape or Unicode your way like out of the proper syntax, and then just by having a weirdly like semicolon drop tables data field.
Yeah.
Speaking of,
Yeah.
you cannot.
Oh, like write to another database
Yeah,
or
you
something.
cannot attack via the indexing process. I think we need to make sure that this statement is true. Like as you're indexing, you cannot attack the.
Yeah.
Another database.
You cannot create.
But even yours that is running it.
Yeah, you cannot create a remote code execution in the indexer just by writing weird stuff into the title of an issue.
Okay. Yeah, that's a good one.
Little Bobby tables as we call it.
Little Bobby tables.
The query part. Let me go to that. Query architecture. So on the query side, this is what it looks like. Basically, I created an intermediary query language. So first the LLM gets the schema up front, and with graph database, it's much easier because you just specify the nodes that are available, and then the LLM can even go in and say, hey, I want to look at the properties of this node. And then I created an intermediary language. So it's literally just a JSON schema. This is why I thought it was like I was very surprised it works as well as it does, where you can basically tell, and I gave the different types of tools. So one is like traverse, find path to another node, right? And then it can input like, I want to issue to assignee of the issue, right? And it can specify the traversal type, and then it can specify number of hops, etc. But the beauty of this is we can parameterize every single input, because Kuzu does do parameterized queries. And we can, when we construct the cipher, we can add the traversal IDs for redaction, and we can validate all input essentially. It just be however good this translation layer is, how secure you are.
But the client can never create the cipher query. You are creating the cipher.
Yes, the client can never create its own cipher query.
Just inject the parameters.
Yeah.
Yeah, but what if node ID is passed in as a cipher query? And
That's why you use parameterized queries.
Okay.
So if the engine, the way they built it is,
It does,
you can't do
escape
cipher
that.
injection. It's just like SQL injection. You can't do it. Now, if they get a bug, like a CV maybe, but still, every tool call will have a namespace path associated to it. So when we expose the tools, the LLM will have to fill out GitLab org or GitLab org / whatever. And the backend, before it even makes it to Kuzu, will say, does the user have access to that project?
But with a project that's got like public, like GitLab, obviously GitLab org, right? Most of it's public.
Yeah.
But there's still confidential issues. So that's only like a,
That's why the
yeah, I know there's a layer
there's two
3,
layers,
but
Yeah.
just to
Like we have a
be
security
cognizant.
right.
Yeah. It's, that on its own is
Not sufficient.
partial.
Yeah, that's why there's multiple layers. I'm just answering Law's question. That's what it kind of looks like, but
But I think this is, at least we have one line of defense against the CVE, because the user cannot create their own query.
yeah, they cannot.
Yeah, if we end up having a detector, because we know what's the thing, we just drop it on the translation layer.
No. Would it be better for us though to research looking into parsing cipher queries, like so you can actually give a direct.
Mike wanted to do that, and I just like.
But
I
the
think
reason, the reason for it is then we're giving people an API that's a actual query language that people can go look up and other people have built, and it's not just us saying, here's some JSON, because it works for agents. It's not going to work for humans.
No, it won't.
And that's who is the ones who we're going to write, who are going to integrate to this database.
So this is creating the same problem we already have with GraphQL. By the way, I love GraphQL. This is not taking a GraphQL. An interpreter that then sends off like arbitrary expensive Postgres queries and a huge exploder.
Yeah.
And so I really like the current API style where like the user cannot supply an arbitrary query and not explode the vacuum.
And we also, for Cypher, you can specify hops, right? So you can specify how many nodes it traverses, like how deep it goes. It's like part of the Cypher language. So you can do 1 to 3 or something. And those are also parameters. So I just do a max of 3, and we can adjust that over time. So we can look at the performance. Is 3 sufficient, or maybe we need to do 2 only and limit it, right?
It's 3 and it's free and the and also to use it.
Yeah.
So
But
we
then
are
again, I
in the
think
launch
this-
block. This is a node.
Huh?
We are in the launch.
Oh, right.
Just one other thing, like with the Postgres, right? Like if we could somehow get it working in Postgres, like it would be so easy, right? Like so much easier. We didn't have to worry about another database. And like, is there not something that we can do? Like, I know modern Postgres has got some new things for doing node traversal. That's not just recursive and all of that. Like, have we exhausted that space? Like, are people totally satisfied that there's no way we can use Postgres as a backend? Because that would be such an easy on-ramp if we could.
I
I'm
would
not
just,
talking
I
about
would,
age.
I would be very hesitant. Like we're having scaling problems with Postgres today,
Yeah,
right?
but you run a separate instance.
Or you're saying you're doing it?
Yeah, of course, not in the main. Like, no. But it's a technology that we know how to deploy. The people who run our instances know how to run.
I
you
feel
know.
like there's no out of the box solution for that. So we'd be writing our own. The only thing is Apache H, from what I saw.
I mean, I've just been scanning around, and there's like people posting about who was the company? There are, because there's sort of the cycle and search stuff in more recent versions, since Postgres 14. But anyway, it's I don't know. It might be worth just doing a little bit.
We
Because
can
if
check.
you could-
There's puppy graph, right?
Yeah.
There's solutions that try
Yeah.
to do graph on SQL relational database.
So this doc that I'm looking at says Alibaba Cloud benchmarked a thing with 12,000 TPS, 2.1 milliseconds per query with 5 billion node in Postgres, right, as a graph database. So that's the kind of like, have we kind of really exhausted it? Maybe age has died because everyone's just using native Postgres now, right? Like, I know it's wishful thinking, but
Yeah, but how do they translate? What query language are they using?
so they're using
Customs.
custom SQL, but using these.
Then we need to write a custom.
Yeah, but that's not hard, right? To turn that into custom SQL. That's it. Just gives you an on-ramp. Like I'm not saying it's definitely a solution, but like we don't have a solution, so it's something to try.
Yeah, we can always do something which I hate, which is have 2 different implementations within. We can use Doing.com and Postgres emulation. I hate that, by the way.
But if there's
Some Postgres emulation self-managed.
look, if Alibaba can do it.
Did you mind ships?
Yeah, of course, I'll put it in the thing.
I do want to go back to that. I believe that the intermediate language, the query language that we choose to expose as our API is really important here because we have to figure out who is our audience. If it's just agents, then like I said before, agents are ephemeral. They're going to figure this out as we go because we're going to hand it to them. But if people are building services that are querying this graph on top of this, we need to be like very, hardcore. Here's our spec for our query language.
I would go one step further. I let me make a claim without any data. I think that our schema for that graph will not be stable for years.
Yes.
We're going to futz around with the schema. So if we have a query language where we're exposing the underlying schema of the graph through the query language, we will have backward compatibility problems. Like every time that we change the schema, like this will be a breaking change. And if we have like this kind of a little bit cooked up API, we can have 7 implementations of the same API.
Well, the way that it works today is if the agent gets the schema up front. So it gets it at runtime. It says, let me get the knowledge graph schema. Then it makes the decisions from there. So if you add a new node, it happens at compile time. It gets inserted into that initial tool call. So that's why I was very surprised because I added CI and vulnerabilities. It picked it up. It knew how to traverse all of
Yeah.
that as soon as I added the new node.
Yeah, but downloading the schema is done by code that you control. Like you're generating that representation of the schema on the fly. So you can have like usu and FactorDB and something else on the server side and always generate the same JSON based.
Yes, you can do that. Yeah.
Yeah.
And we can migrate the
Yes.
users, and you can even fake up correct field names if you really
Mhm.
need to.
Yes.
One question regarding the like query language. I remember that we have, and I haven't used that. But like GLQL, like it probably does not support graph like.
I tried GLQL, LLMs just don't know it. And that's why this worked really well, because LLMs know Cipher. So you tell the LLM this is Cipher like essentially, and so it can.
Exposing GLQL to the I understand. So
You have to expose the entire GLQL corpus and syntax because it's just not trained on it. And that'll just take up this, like, removes the point of.
But GPT-6 will be trained on GLQL because, you know.
Yeah, the one thing in the handbook. I don't know about that.
Stan, you're the time manager.
Yeah, I think we should take a lunch break. Yeah, I think that's what you were trying to ask for. Just say, can we lock the room or do we have to?
Should I?
I think it's 30 seconds.
Yeah.
That's good.